Hello, students. Welcome to the Unit 8 Notes, Section 12.1. At this time, if you want to try the warm-up on your own, feel free. Don't forget to use the distributive property for numbers 1, 2, and 3. At this time, I'm going to start to go over the warm-up. So we're going to use the distributive property. Make sure you do multiply all the terms together. P times P is P squared. P times 3 is 3P. 3 times P is 3P. And 3 times 3 is 9. So we get P squared plus 6P plus 9. All right, second one, we're going to do the same thing. We're going to make sure we multiply everything together. We get W squared plus 10W plus 10W plus 100. And we'll combine like terms. So W squared plus 20W plus 100. And the last one, this one has negatives, so just be careful. So M squared minus 2M minus 2M. Don't forget, negative 2 times negative 2 is actually a positive 4. So this one we get M squared minus 4M plus 4. All right. Find the value of x, leave your answers in simplest radical form. It looks like we're going to be using the Pythagorean theorem for these. So don't forget that Pythagorean theorem is L squared plus L squared equals H squared. So 8 squared plus 16 squared equals X squared, because this one is my hypotenuse. For this one, I'm just going to label them all while we're here doing this. Make sure that the hypotenuses go in the correct spot. So we have 64 plus 16 squared is 256 equals x squared. So 256 and 64 combined is 320. So we're going to find the square root of 320 and the square root of x squared. So x is equal to plus or minus. Don't forget, we can't have a negative value, so we'll just say the positive value of the square root of 320. And we're going to have to do, we're going to have to find it in simplest radical form. So I'm going to break this down a little bit. 32 and 10, 16 and 2, and 5 and 2, and 4 and 4, and 2, 2, 2, 2. So we have the square root of 2 times 2 times 2 times 2 times 2 times 2 times 5. So we're going to pull one set of 2's out. Pull one set out. We'll pull another set out. We'll pull a third set out. So we have 2 times 2 times 2. We still have the square root of 5 left over. So it looks like we have 8 square roots of 5 as a result. So x equals 8 square roots of 5. All right. I'm going to check my work real quick in the calculator. I'm going to get an approximate value for each one and see if they're equivalent approximate values. So the square root of 320 is about 17.8885. 8 square roots of 5 is about the same exact thing. So I think I simplified that one right. right, this next one, going to put a divider in here so that we can separate the work. All right, this next one, we will do x squared plus 13 squared equals 17 squared. So we have x squared plus 169 equals 17 squared, which is 289. Take away 169 from both sides. We have 120, so x squared equals 120. So x equals the square root of 120. X equals, we're going to have to simplify this one. Let's put in a divider for number 6. Okay, 120. How about 12 and 10? 4 and 3. 2 and 5. 2 and 2. So it's the square root of 2 times 2 times 2 times 3 times 5. Looks like only the 2's can come out. So these are going to come outside. And inside we have 2 times 3 times 5, which is 30. 2 times 3 is 15. And 2 times 3 is 6. 6 times 5 is 30. So I believe we get 2x equals 2 square root of 30. Now you could have used the greatest perfect square for these. Like 120 is 4 times 30. So the square root of 4 is 2. Like this one, 320, it could have been 16 times, actually it could have been 64 times 5. Yeah, and so the square root of 64 is 8. If that method's easier for you. This last one, we're going to get x squared plus 16 squared equals 20 squared. So 16 squared, I get 256, oops, equals 400. So x squared, let me move that over a little bit. So take away 256 from both sides. X squared equals 144, and so x equals the square root of 144. So x equals 12. That one was much more simple than the others. Not much that we had to simplify. All right. So these basic skills will come in handy, and we'll show you where that's going to happen. So we have this lesson's about tangent lines. So remember in our first lesson in 10.6, we talked about what a tangent line is. It's almost like if you take an egg and you lay it on a table, the point at which the egg, the curvature of the egg is touching the table, that is a point of tangency. The table itself is the tangent line. It's only touching the egg in one spot, just like a tangent to a circle only touches the circle in one spot. So you see here that you have your tangent line to a circle, line AB, and you also have the point of tangency, point B. All right. The reason why a line is 180, look at it, the whole arc that it intercepts is 360, right? The whole circle. So that's pretty cool to see. We also have a tangent ray, BA. We also have another tangent ray in the other direction, B whatever, if we want to add another letter to our line, then like R, it would be BR would be an opposite ray that's also tangent to the circle. What's cool about tangent lines, and this is our first theorem, is that they're perpendicular to the circle. So here is OP, it's perpendicular to a radius. And it doesn't matter, as I spin the line around the circle, it will always be tangent. So we have two right angles right here. So we have APO is a right angle and BPO is a right angle. So we could actually say that. We could say the measure of angle APO and the measure of angle BPO. So APO and BPO is 90 degrees. So going on to our next theorem, if a line in a plane of a circle is perpendicular to the radius, then it's tangent. So this one's saying a tangent line is perpendicular. This is saying if it is perpendicular, then it is tangent. So now I can conclude for this one, the conclusion is that line AB is tangent. So it's just going in the reverse order. Is tangent, to circle O. Oops. All right, using tangents. Here's what's also really cool. The two segments here are tangent, and they intersect at a point outside the circle. So look we have AB, that's tangent to circle O. We also have CB, which is tangent to circle O, and it's almost kind of like a ice cream cone. We have AB and CB, and they're actually congruent. So think about a cone with a scoop of ice cream, right? Those parts, what makes up the cone itself, those are congruent because they intersect at a vertex. They intersect at a vertex outside of the circle. So going up to this example here, let's put some tick marks on this one. We got, these are congruent. Those are the cones. This one's another one. And then here's a third one. Be cautious. Some students will do this, and it makes me nervous. Those are not the congruent pieces. Oops. Those are not congruent. Be careful. It's what makes up the cone, okay? So I'm going to label it again. So let's put 1 tick mark, 2 tick marks, and let's put 3 here. Now let's add numbers to it. If this was 5, that would be 5. If this was, that would probably be about, 17. That would be 17. And let's call this 28, and that would be 28. So what you can do, if you know the whole length of something, you can use subtraction to get a piece of it, or you can use addition to get the whole thing. That's what we're going to be doing a little bit today as well. So, oh yeah, and I think we're good with that. So let's do a couple practice problems. Here we have that the question is that ML and MN are tangent to circle O. And they want us to find the value of X. Well, if LM is tangent, then the first thing I want to do is put in a right angle and say, okay, yep, let me use what I know, that this is a right angle. Oops. Also, MN is a right angle. So this question's already coming together pretty quickly. What I need to do is I need to find X, which is angle LMN. And the way to do that, knowing that this is a quadrilateral, we have 4 sides, meaning that we're going to have 360 total degrees, right? So we're going to do 90 plus 90 plus 117. So we're going to do 180, 180 plus 117, because I know that so far I have 297 degrees in this quadrilateral. Then I'm going to do 360. I'm going to take away the 297 that I already have listed, and that's going to leave me with 63 degrees. So x is going to have to be equal to 63 degrees. And we're done with that problem. A lot of students make a mistake where they think that they're congruent, but remember, quadrilaterals have to add up to 360. So use what you know about angle L, it being 90, and angle N being 90, because those are tangent to the circle. And then use what was given, the 117. Here's another one where you have a tangent. So DE is tangent. Whoops, DE is tangent. So we're going to put that in here. That's 90. And you already have 38 on the other side. This is a triangle, so we're going to add 38 and 90, and we're going to get 128 degrees. And so we're going to do 180, take away 128, and we get 52 degrees. And very quickly we find that that has to be 52 if this is going to be a triangle. And if DE is going to be, tangent to circle O. So ED is tangent to circle O, so x equals 52 degrees. All right, that one's done. Next, find a tangent here. So is the measure of angle is ML tangent to circle N at the point L? Well, we can't assume that this is a right angle. They're asking this, right? They're asking, hey, is that a right angle? Is that tangent? Well, what are we going to do here? We are going to use this triangle and these pieces right here. We're going to use 25, 24, and 7. And we're going to say, hey, if this was a right triangle, it would actually have to abide by the Pythagorean theorem. So that's why we did this earlier, the Pythagorean theorem, because it's going to be relative. We're going to say, does L squared plus L squared equal H squared? So is that happening? If this is true, then we have a right triangle, and that would make it tangent. So we are going to put numbers in. 7 squared and 24 squared. Does that equal 25 squared? Okay, how did I know to use 25 there? Remember, if this is a right angle, which I can't assume yet, if it was, across from it would be the hypotenuse. So that's why I put 25 there. So that's the, here, I'll put this. Is that a hypotenuse? And we're going to do the algebra out now. So 49 and 24 squared is 576. And that's 625. So does 576 plus 49 equal 625? And guess what? We're in a really good spot. It does. That means that this is a right triangle. And that does mean that that's a hypotenuse, because hypotenuses only happen in a right triangle. And therefore, we can say that ML is tangent to circle N at point L. Because angle Oh, that froze. Sorry about that. Because angle L is a right angle, because we could even further say because triangle MLN is a right triangle. I mean, you don't have to even go that far. You could just end it at angle L is a right angle. All right. This next one, we're going to throw some new values on this and see if that's also true. I have a feeling this one might not be, because 4, 7, and 8 don't look like really good numbers for perfect squares that all connect. But let's actually do this. We can't just assume. We're gonna label this 4. We'll label this one LM is 7, and this would be 8. Again, if it was, this would be the hypotenuse. That's the question. Can that be a hypotenuse? So we're going to do L squared plus L squared equals H squared. We will do 4 squared plus 7 squared equals 60. I'll write it as 8 squared. 16 plus 49 equals 64. 16 plus 49, so 40, 50, 65 equals 64. That is not true. So, not true, not true, not true. That's not true. So 65 is greater than 64. This is actually an acute triangle. So we are just going to say ML is not tangent to circle N at point L, because angle L is not a right triangle, is not a right angle. All right. Example 2. This one I would normally give you guys some time to contemplate how to answer it. It takes a while, it takes a little bit of thinking to really break it apart and to answer the question. But here, let's go through it together. A dirt bike chain fits tightly around 2 gears. The chain and the gears form a figure like the one at the right. Find the distance between the centers of the gears. So when we go over this, there's a lot of labeling that's occurring, but there's no way for us to, for instance, make a right triangle. That's what I'm tempted to do, right? Is to make a right triangle. But that is actually not a right triangle. That's a quadrilateral. It has 4 sides. We can, however, because we want to know the distance between the centers of the gears, and that's what I just connected, right? We might not be able to make a triangle from that moment, but we can make a triangle this way. So what I did was I took my quadrilateral, knowing that I see those 2 tangents at the top, knowing that they're 90 degrees, I actually broke apart this quadrilateral into a rectangle and a triangle. And so this label, I'm going to label this, because it's a rectangle now, and I know this because I have see these right angles here? This right angle and this right angle means that this has to be a right angle and this has to be a right angle. So I'm going to put those, I'm actually going to draw those in. I'm going to label this as 26.5 inches because they're parallel, and they're both sides are 26.5 inches. Now this whole thing here, this whole thing is 9.3. But if I'm looking to make this a triangle, I need to figure out what this piece was and take it away so I can find this piece right here. 9.3, well, I know that this part on this side is 2.4. So I quickly do a little algebra, 9.3 minus 2.4, and I'm going to get, I just want to make sure I don't mess this up, and I get 6.9. Yep, 6.9. So I now know that this part's 2.3. It's not gonna, that part's not gonna matter. 2.4, sorry. That part's not gonna matter. One more time. This part right here now, I'm going to write that. So I broke up 9.3 into 2.4 into 6.9 inches. So now I have everything that I need to find the distance between these centers. So I'm going to do leg squared plus leg squared equals hypotenuse squared. I'm going to do 26.5 squared plus 6.9 squared would give me the hypotenuse, which is x squared. All right, 26.5 squared is 702.25. And 6.9 squared is 47.61. And now I'm going to add those together, and I get 7. Okay, now I'm going to move this so it's not, we have some room. 749.86. So x is equal to the square root of that. Now, this is a real world problem, so I'm not going to leave it in radical form. I'm going to approximate. So x approximately equals 27.3835. Let's round it to, does it say? Find the distance between the gears. Okay, let's round it to 38357. Let's round it to the nearest tenth because that seems reasonable for inches, right? So, or we can do hundredths. Let's just do tenths of an inch. So there we are. The length of the distance between the centers of the gears the distance between the centers of the gears is approximately 27.4 inches. All right. We have another one. This involves a pulley system. I don't know if you've ever seen a pulley system. Sometimes if you go by like a construction site, or even like, let's say someone's getting their roof shingles replaced. After they scrape the old shingles off, sometimes a package of shingles are very heavy. So they'll use a pulley system on the ground and on the roof to pull it, stacks of them, multiple stacks at a time, up the pulley system to put them on the roof. That's just one example of a pulley system, but because one of the circles is larger than the other, it actually makes the work easier. Anyway, a little fact there. We're gonna a little fact for this lesson. All right, so we're gonna do the same thing. 8 and 8 inches. that's going to make it 6. So that whole length was 14, but just doing it quickly, 14 minus 8 is going to be 6. So we have 6 and we have 35 inches here. And we're going to try to find the length of this in inches. So we'll do the same thing. So 6 squared plus 35 squared equals x squared. And we have 36 plus, 36 plus 1225 equals x squared. I just want to make sure my numbers are right. Yep. 35. Okay. And so add, so 1261 equals x squared. X equals the square root of 1261. It's a real world problem. Let's not leave it in simplest radical form. That would be strange. So x approximately equals 35.51056. Uh, 51056. So x approximately equals, let's do the nearest tenth. So 35.5 inches. We're going to round off the rest, and we are going to write it in a sentence. And I'm just going to change the word gears to pulleys. P-U-L-L-E-Y-S. Pulleys is approximately, those are all inches, yeah, 35.5 inches. All right. Good, good. All right, so we're done with those. These are a little bit easier, I think. We can do one of two things. We can find the perimeter, or we can use the perimeter and work backwards and find the missing pieces. So let's see, circles inscribed in polygons. So circle O is inscribed in ABC. Find the perimeter of ABC. Oh no, I got these questions backwards. This goes to this question, and this one goes to this one. I apologize for that. So let's focus on the one below. Notice we wouldn't be able to find the perimeter of this one because we don't have enough pieces. We would need at least one of each piece. So this one though, if we want to find the perimeter, we know that this piece is congruent to this piece, that this one is congruent to this one, and these are congruent. The reason being, again, remember, think about the cone. So it's C, A, B, and C are the points where the tangent lines are intersecting. So it's meeting at A, meeting at B, and meeting at C. So those are the pieces. So we have 8 centimeters, we have 10 centimeters, and we have 15 centimeters. So the perimeter is going to be 8 centimeters plus 8 centimeters plus 10 centimeters plus 10. Now, some of you are going to notice a pattern. You don't have to add all 6 of these. You can add the 3 unique ones, and then times it by 2. I know some of you are already thinking that. That's okay to do. And So you would, if you did that method, you would have got 33, and you would have multiplied it by 2. Here we have a total of 66 centimeters. All right. Circle O is inscribed in PQR. So this one, again, these are backwards. So we have, it's inscribed in PQR. It has a perimeter of 88. So we already know the perimeter. We want to know what QY is. So what I can do, I'm going to mark this up a little bit. I'm going to say, well, I know this is congruent to this is congruent to this one, and this is congruent to this one. And I'll label what I know. So now that's 17 centimeters, and that's 15 centimeters. I don't know what these are, but I can call both of them x if I want to. It's a variable, and I don't need to use two unique ones because we do know that they are equal to one another. So I'm going to set up, I know that the perimeter is equal to, let me see, it was 15 and 17, so it's going to be x centimeters plus x centimeters plus 15 centimeters plus 15 centimeters plus, whoops, plus 17 centimeters plus 17 centimeters. Yeah, that's all good. I am going to label these centimeters up here. So I already know my perimeter is 88, so I'm going to substitute that piece of it in. So 88 centimeters equals 2x plus, and I have 64. 64 centimeters. So I'm going to take away 64, and I get 24. So I have x is 12, and because x is the same thing as qy, I'm going to say that. I'm going to answer it the right way. QY was my solution. So QY equals 12 centimeters. All right, a good way to check, just add them all together again. 12 plus 15 plus 17 times 2. I get 44 times 2, and that's 88. So I did everything correctly there. All right. Let's take a look and see if there's anything I think you're going to need help on. I think you're good with 1, 2, and 3. That one, again, just think about your figures. The first one's a quadrilateral, so it's 360. They have to add up to 360, so draw your angles in, right? Your right angles, and go from there. Ooh, this one's a little bit tough. Let's take a look at this one. Well, if that one's 60, we know that that angle's 60. Oh, take a look at this. This is cool. All radiuses are congruent, right? So they're all the same length. Well, looks to me like you have an equilateral triangle. So, well, okay, at first we notice it's isosceles, right? So that's 60, and then this one's also 60 because they both have to be the same thing. And mathematically, there's nothing left over except for 60. So we actually have 3 congruent angles there. This one has to be 30. It has to be 30 because you have a right angle there because it's tangent. You have a tangent to the curve, so that collectively has to be 90 degrees. Mathematically, you'll do 180 take away 120, which is 60. I'm sorry, my apologies. I am one step ahead of myself. Take away 60 and get 120. and that's going to go right there because I just did, it's a line, so I just took away my 120, sorry, my 60, and I got 120. So mathematically, this one then will have to be 30 degrees. You can also look, this right here, if this angle's 90, and you know that this one's 60, then that has to be a 30 because this whole thing on the outside is a triangle as well. So there's a couple ways to solve this one, but I'll let you figure out which method you like the best for solving that one. These you're going to use the Pythagorean theorem for, right? We're going to do L squared plus L squared equals H squared, see if it works. These perimeter ones, you know what we didn't do? We didn't do one like number 12. So in number 12, I'm going to first mark the pieces that I know that are congruent. So this one, and this one. Now, it looks a little bit confusing. You almost want to make this side 3.6, but that's not what we're going to do. I know that this is 1.9, so look at how this part is 1.9. This part's also 1.9, right? If this is 1.9, and I know the whole thing's 3.4, if I take 1.9 away from this 3.4, I'll be able to break 3.4, the whole length, into two pieces. So I'm going to do 3.4 minus 1.9. And 3.4 minus 1.9 is 1.5. So I get, oh, I am not sure what just happened. Here we go. Let me exit. Let's go back. All right, we're back to normal. So 3.4 minus 1.9 is 1.5. So 3.4 is going to break up into 1.9 and 1.5. Does that make sense? So I'm just using the fact that I already know that part of this is 1.9. So this part's 1.9. So now I'm going to do that a bunch more times. I'm just going to keep going around and around. So 3.6 take away 1.5 is 2.1. Okay, so 3.6 is no longer 3.6. It's 1.5 on this side and 2.1 on this side. All right, now I'm going to do this again. 3.7 minus 2.1 is 1.6. So 1.6, and this one's 2.1. Oh, and look at that. I found the one last missing piece. So that is another strategy. Just go from, just keep going around and taking the pieces away that you need to take away to find that, to break that side up that you were given. And right now, I am going to add them all together. So the perimeter is going to be equal to 1.9 plus 1.9 plus 1.5 plus 1.5 plus 2.1 plus 2.1 plus 1.6 plus 1.6. So the perimeter is equal to 14.2 inches. All right. 11 is a little bit easier. You're just going to go around and add them all together. And we'll do one of these. So, Pythagorean theorem, you're all good for this one. Pythagorean theorem, that's your, this right here is your hypotenuse. For 14, look at what you have for a hypotenuse. You have 7 plus x. Remember the warm-up, how I said you're going to have to use the distributive property? So we are going to find what would make it tangent. So we're going to do L squared plus L squared equals h squared. So 10 squared plus x squared equals, in theory, well, not in theory, but in actuality, this would have to be your hypotenuse. So we're going to do 100 plus x squared equals, you have to use your distributive property here. So you're going to get 49 plus 7x plus 7x plus x squared. That's why we did this in the warm-up. We're going to combine like terms. So 100 plus x squared equals 49 plus 14x plus x squared. Oh, and look at this. The x squareds will go away. So 100 equals 49 plus 14x. Take away 49. 51 equals 14x. And so now we're going to do 51 divided by 14. And we're going to get x is equal to approximately equal to, let's round nearest tenth. We get 3.642857. So x approximately equals 3.6. We round the rest off. It doesn't round up. Okay, so that should prepare you for number 15. Those are pretty much the only questions I think I got last year for the most part. So your job is to, your task is to finish notes 12.1, to finish practice 12.1, and to ask any questions that you have during the Google Meet. And I think that is it. Enjoy.